Mobility is an important issue in internet. The number of mobile devices is increasing. The wish of the users to connect to the internet in each position they are, on each location they visiting. So mobile computing is a must. Mobile computing stands for systems and communication networks with mobile end systems. There are different technologies in place. This mobile networks can use and can operate on radio waves. They can use infrared. They can use other types, Bluetooth or other types of technologies. We already discussed wireless local areas. You know, the mobile phone networks. All these technologies, all these network technologies, wireless network technologies, provide in principle the possibility to also connect to the internet. If we look back to IP version 4, then mobility was not at all a problem as long as a mobile device belongs and stays in the area of the local network. Because there is a local address, you remember there is a network address and a host address, and as long as the network is not left, it works fine. But in IP version 4, it becomes a big problem if the mobile device left the local network and wants to connect in another network to the internet. Then the IP address of the mobile system has a wrong network ID. So the change of the IP address is necessary when the mobile system moves to another local area network and wants to use the other local network for connecting to an internet. Such a change of the IP address has a lot of consequences. So all the applications communicating with this mobile host need to learn the new IP address for continuing to communicate with the mobile system. So it's really a big problem, the mobility in the IP version 4 context. Therefore, it was a design task for the internet working with IPv6 that the protocol also allows that mobile devices, really mobile devices, can connect to the internet. So for that reason, the so-called mobile IP version 6 protocol is an integral component of the IP version 6 internet protocol. Now, what is the basis idea of this mobile IPv6? The basic idea is that a mobile system, has two IP addresses simultaneously. So one address is the primary IP address. This is also called home address. This is the address like every system has the IP address, and typically it's a network it belongs to in most cases. And then there is a secondary IP address, and this is also called care-of address. And the care-of address change with each change in location. And the mechanisms are designed in a way that the home address takes care about all the connections on the application level. And the secondary address is used for organizing communication also in other networks. Let's have a closer look to the primary IP address and their functionality. This is the stationary IP address of the mobile host in its local home network. This primary IP address always remains unchanged. Always remains unchanged, even if the local host, even if the mobile host changes the location and comes into the range of another network. So all the applications that are running on the mobile host, they use this primary IP address. In this way, all the application does not realize and are freed from taking care where the mobile host in this moment is located. Application every time works with a stationary home address. The secondary IP address, also called care-of address. This secondary IP address is only temporarily valid. And it's only valid in a certain network the mobile host is just visiting. So the secondary IP address changes with every location, and is only valid as long as a mobile host is a part of this guest network. So now we see the concept, the home address. This is a stable address. All the applications work with the host. And this care-of address helps that the mobile device can use network resources from different networks. So now the question is how the secondary IP address, a mobile host can get such a secondary IP address. So let's imagine host is moving and comes in the area of another wireless local network. Then the mobile host registers in this new network. And this registration is dealt in the same way like every time if a host is connected to a network. So in the guest network, the mobile host gets a secondary IP address, and now the mobile host sends this secondary address to a specific agent, the so-called home agent. Typically, it's a router in his home network. So the router in the home network does know, of course, the primary address of a mobile host. And after this announcement, the router also knows the secondary IP address. Now the home agent is able to forward all the data that are sent to the primary IP address to the mobile host, because the home agent knows his actual secondary address, its care-of address. In this way, all the application, it's not necessary that all the application knows the secondary address. It's enough that only the home agent knows it and takes care that the packages which are sent to the home address are delivered to the right and actual secondary address. And the home agent sends the data package, forwards the data package which were originally sent to the primary address to the secondary address. One speaks here also from IP to IP encapsulation. So the application of a mobile host have no knowledge about care-of addresses, so it's no problem if the care-of addresses is changing frequently. Only it's important that the home agent every time knows exactly where the mobile, in which network the mobile host is actually located, and what and how it can be reached in this guest network via this secondary IP address, via this care-of address. So the home agents take care of to forward all the information to this network. How this care-of address is allocated to the mobile host. Mobile hosts reach the area of, say, a wireless LAN, and then it requests a care-of address. For the guest network, it is the same type of address like for the stationary computers in this local network. So the guest network, there is no distinction between addresses that are used as care-of address or whether used as home address. It is simply an IP address. The distinction comes from the way it is used. So the mobile host requests an IP address and he gets an IP address. We remember that there are different mechanisms available in IPv6 to receive such an address, for example, by auto-configuration with NDP or by auto-configuration with DHCP. And then the the guest address, the care-of address, is assigned to the mobile host. As I already mentioned, the router cannot distinguish between the mobile and the stationary hosts in the guest network. For that reason, the auto-configuration mechanism is so important, so that's easy to deal with such type of mobility. The mobile guest computer carry out forwarding the management on their own. So low protocol layers operate with the care-of addresses, and the application and the higher layers, they operate with the primary address. Let's have a closer look. Here we have a mobile node. MN is a mobile node. The mobile node, which is originally here in the home network. This big is the internet. So that's the home network of our mobile node and the home network. And let's assume that the mobile node now moves to another guest network, the visited subnetwork. So the mobile node moves to a foreign network and then it requests the care-of address registering in this guest network. Then, in a second step, the mobile node forwards the care-of address to the home agent. Here is the home agent. So that the home agent knows the care-of address of our mobile node. Home agent knows the primary address. So home agent can manage the forwarding of the data packages. The home manage sends back an acknowledgement so that the mobile knows exactly knows that the home agent can take care in this forwarding all the messages that are sent to the primary address of the mobile host. Then in the third step, we have a communication node. A communication node that wants to communicate with our mobile node, that wants to, for example, runs an application which wants to communicate with the corresponding application on the mobile node. Then the communication partner wishes to contact the mobile node, so he sends all the information to the home address, to the primary address of the mobile node. The home agent receives this, home agent is a router typically, receives these messages and sees, okay, these are messages sent to a host with a primary address, and it knows that this host is exactly in this moment in this visited network. So it takes and gives back the care-of address, and then communication can be organized in a direct way. So the home agent tunnels the communication partner messages to the care-of address of the mobile node in a way to put it into IP packages which are sent to the care-of address of the mobile node in the guest network, and then the mobile node can see these messages and can answer it to the communication partner in a typical way. When the mobile node answers the communication node, it gives the current care-of address by way of a router heading. And the idea behind that is that on the lower level, the communication partners can directly interact with the care-of address of the mobile node and because the addresses say something about the network. It's important for an efficient routing in the internet that the system knows the network address. So here the communication node and the mobile node can now communicate directly with this care-of address. And if the mobile node again moves into another network, then via the home agent, the communication partner can learn the new care-of address and then continue to interact with our mobile node with the new address. When the mobile node leaves the foreign network, then of course it has to tell this to the home agent. It has to release the care-of address again, has to notify the home agent, though that the home agent does not forward messages which are sent to the mobile node to this care-of address in this guest network, because mobile node, for example, moved now into the next network, and then same game. It has to get a new care-of address. It has to communicate this care-of address to the home agent, and then this works. So you see, it's in a very sophisticated way with this mobile IPv6, which allows that hosts can be mobile and can access wherever they are in a very simple way, in a very efficient way, the internet, without that all the routing tables have to be changed, without that all the applications, the running applications need to be informed. This is simply mechanisms which only need home agent in the stationary network.